Lads, hopefully I'm getting a wee bit better at this. Here's another review session on the multiplication and division of algebra. So we did a quick recap of the rules, but here's a good opportunity for you guys just to practice that. Just I've got about 10 practice problems there. You should just pause the video now and give them a go. Alright lads, welcome back. You've probably done these problems pretty rapidly. We've been doing quite a lot of them this term, but it's just good to make sure that all this content is available for both those top classes. So you guys should know that if we have r times r times r, then that's just the same thing as saying r cubed. You can pretty much just read that one off straight away. But also remember that there is a power of 1 on all of those. So you could also say that that's adding those powers up. What some people struggle with is when there's a number in there, but just treat that like any other variable. Alright, can you put 2 and y together? No, you can't. So I've just got 2 lots of whatever these variables are. And we've got the same relationship as we did with the r squared. So that's just 2y cubed. That's 2 times y to the 3. Remember, order does not matter with multiplication. I've tried to make this really clear. That is a q and that is a p. Because they're different variables, we can't just put them together into one thing. So that's going to be 2 and 3 are fundamentally the same variable. They're constants. So that's 6. We always do our numbers first. And then Q and P, well, they're not like terms. So we just say that is 6QP. This is a similar problem, but now the variable is the same. So we do our numbers first, 8, and that's going to be A times A, so that's A squared. I'm expecting you to have 4 out of 4 so far. And then this one is a little tricky. This is why we stylize the x variable, so we don't get it confused with the multiplication symbol. So we've got 3 times 2 and no other numbers. Well, we've got 1s everywhere, don't we? So that's 3 times 2 is 6. And now the powers, well, what are our powers going to be? Well, that's 1, 2, 3, 4. That's x times itself 4 times. Sweet. So those are 5 really simple problems based on that last video. So hopefully you've got 5 out of 5. If you've just made a silly mistake, don't worry about it. If you've really struggled on that, you need to message me, and we might get a wee Zoom chat going sometime tomorrow, and we can just go through some of that. I'm really wanting to try and get a down camera for the Zoom so I can get a vertical camera going, but you know what teachers are like with that technology. We would probably need to spend some money there, wouldn't we? X cubed divided by x, that would just be cancelling out 1 power. So you could write this as, make sure that's in the shot, I'll just be writing that as x cubed over x, and we can cancel a power top and bottom and call that x squared. We could use our rule of subtracting powers and call that x to the 3. This one's nice. Again, just like in multiplication, we work on our numbers first. Well, 24 over 12, that is 2. Not a half, but 2. That is a 2. So we would leave that, if this was a fraction, it would be on the top. And then we've got x to the 4 next to that, so that's 2, and then we can cancel 2 out of the x is 6, got x to 4. With our numbers here, we've got 5 over 2. Well, that can't be simplified, can it? So that's just going to stay as 5 over 2. And now I need to determine if my x's are going to be on the top or if they're going to be on the bottom. And we've got x squared on the top. So that's your answer, 5x squared over 2. You may have written it like this, 5 over 2 times x squared, and they're equivalent. They're the same thing, aren't they? I like to have my x's in the numerator. Just in case I'm going to be cancelling down, it just makes things a wee bit easier. Right, this gnarly thing looks pretty scary, but we just look at that 12 over 3, and we know that 3 goes into 12 4 times. Now we look at the next variable. We just usually do it alphabetically, and we're going to see that an x is going to cancel top and bottom, and we're going to be left with x to the 1, but we don't write the 1. It's just x to the 1 is like that. And you'll notice that the same thing happens with the y's. We have a y to the 1. So that whole thing there actually just comes down to being something like that. And hopefully you've got 5 out of 5, and hopefully I haven't made any mistakes. So just like most of our lessons, that was a quick little 10 question starter for you to do, and then a little bit of new material for you. So what I've got here is I'm just going to go through the square root function. So something a little new. I don't believe I've gone through this in class. Now that you're locked inside your house, you can't really escape the square root, right? All of these things are locked inside that square root function. The easiest way to look at this is what two things would multiply to give 9y to the 6? Because remember, that's what the square root symbol is doing. It's telling us if we were to square root 16, you would tell me that that's 4, well, plus and minus 4, right? So you're telling me that what thing times by itself gives you that value. So, well, what two things would multiply this? And you could try and error this, so you probably understand that that would be 3y cubed, wouldn't it? Because if you were to times 3y cubed by itself, you get 3 times 3, which will give you 9. And you know y cubed times y cubed, you would add the powers and get y to the 6. But what's really interesting is that square root can just act on every single thing in there independently. So the square root of 9 is 3, and the square root of y to 6 is y cubed. So this one, you could give this one a go now. Make sure you're pausing that video, because I'm not going to wait here for you guys to do that. I'm just going to get stuck straight in. And that's going to be the square root of 25 is 5. We're just going to go with the positive with these. I know there's two answers to that, but we're just going to go with the positive. And the square root of x squared, well, actually that's the whole reason we do square roots, right? Is to cancel the squaring. So we can just say that that's 5x. You could check this, times it by itself. 5x times 5x would give you 25x squared. Hopefully you're seeing a pattern now. What's happening with the powers when I square root? Well, that power's been halved, and so is that. Still not enough to really devise a pattern, but what times itself gives x to the 16, x to the 8. All right, we're seeing it 3 times now, halving that power. So we're just going to have to halve this power, so we're going to get y to the 50. But what's the square root of 100? Well, it's, as you know, it's 10. So, what about this thing? Well, we've noticed that we can act on a number and then a variable independently, do one then the other. And so we can when there's more than one variable. So let's do the 36. Square root of 36. 6 times 6 is 36. So that is indeed 6 out the front. We can half the power, or think about it like what times itself gives x squared, and it's just x. And now we've finally kind of understand there's a wee shortcut there. We can half the power, so that'll be y to the 2. Good. So what that means for us in terms of square root, if we square root two things, they're multiplied. So if we square root a times b, well, we can actually say that that's the same as square rooting a and square rooting b. The other rule for our square root is that if I square root something, if I square root anything, that's actually the same as raising something to the power of a half. We might come back to that. At a later date. But here it is. You can separate the multiplication out. That is a cool wee square root rule that you might want to just chuck in your record of learning. Square root AB is the same as square root A times square root of B. We could think about let's have a look at, say, square root of 81. Well, square root of 81 we know is 9, okay? But that could be the same as the square root of 9 times 9, which is the same as the square root of square root of 9 times the square root of 9, which is 3 times 3, which is 9. So you can see that power, that is working, right? So that's a nice little rule for us to keep in our record of learning. All right, stay tuned for expanding and factorizing and powers of powers. Smash that like button, like that smash button.